Hello everyone, welcome to Mathematics Meal. This program is a wonderful program that has helped a lot of students, so it's important that you partake in this program. Do well to subscribe to our YouTube channel and also like our Facebook page. Follow us on Facebook, it's necessary. Today on Mathematics Meal, we are still on theory of logarithm. Remember that we have looked at the meaning of logarithm, the laws of logarithm, and simplification of terms and expressions involving logarithm. Today we are looking at a different aspect of logarithm, and that aspect is the aspect of logarithm of numbers by substitution. Logarithm of numbers by substitution. Now, we know what substitution is all about. We know what substitution is all about, to replace. That's what we mean by substitution, to replace. That's substitution. So we can find logarithm of numbers by substitution. If I have a given number, let's say I have a 6, and I want to find logarithm of 6, I can use the logarithm of other numbers to find the logarithm of 6 by using the logarithm of other numbers to replace log 6 in a given word expression. That's what we mean by logarithm of numbers by what? Substitution. So we say the logarithm of a given number can be found by substitution if the logarithms of other numbers that can be combined to form the given number are what? Known. If we know the logarithm of other numbers that we can combine to form the logarithm of to form the given number, then we can actually find the logarithm of that given number by what? Substitution. So how do we go about it? We say to do this, we take these steps. Already we have questions that we have written down that we need to solve. So they say we take these steps. What are the steps that we need to take? Take note of the unknown word, logarithm. So here we are going to be applying the steps to solve this question. They say if log 2 in base 10 is 0.3010 and log 3 in base 10 is 0.4771. They ask us to find log 6 in base 10. So question A is log 6 in base 10. We needed to find it. So they say take notes. Take note of the unknown logarithm. We don't know the logarithm of 6. Also take note of the known logarithms. So we know the logarithm of 2 and the logarithm of what? 3. They are the known logarithms. So they say using appropriate laws of logarithm, express the unknown logarithm in terms of the known logarithms. Now, there are so many laws of logarithm. Is it possible to split 6 in terms of 2 and 3? Yes, it is. Why am I splitting 6 in terms of 2 and 3? We go back here. They say using appropriate laws of logarithm, express the unknown logarithm in terms of the what? Known logarithm. So the known logarithm are logarithm of 2 and logarithm of what? Of 3. They are the known logarithms. So if I want to handle this, I must express what? 6 in terms of 2 and in terms of what? 3. And how do I do that? There are two possible operations that we will use. Two possible operations that must be used in splitting these numbers. What are those operations? One is division and the other one is what? Multiplication. So if I want to form 6, I need to multiply 2 and 3. You see that? So two possible operations that I can use in the simplification or in solving this logarithm by substitution. I carry out division or I carry out what? Multiplication. So remember that we have a law in logarithm that can either combine multiple log or reduce multiple log to a single log. So if I express 6 in terms of 2 and 3, I'll have 2 times 3. You know, I've not changed anything because 2 times 3 will still give me what? 6. Okay? So they say express that using appropriate laws. We have not finished in the expression. We haven't. Because we don't know 2. What we know is logarithm of 2. Now you remember that our first law in logarithm, we have log base A plus log that will give me log m times n in base a. That means if I have two logarithms of the same base and the operation between them is addition, they are added, I have the right to multiply the numbers under their common base. In other words, if I have numbers that are multiplying under a common base, I have the right to take this. I can write the whole of this in this form. If it is in this form, I can decide to write it in this form. So this can move to this, and this can become this. So in this case now, we don't want this to remain like this, because it will not help us to solve our problem. So we need to take this from here and write it in this form, as far as this is concerned. So if you look at that, you will now see that log 2 times 3, this is like m and the word n now. So if I take it to the other side of that log, I'm going to have log 2 in base 10 plus log 3 in base 10. You see that? Why am I writing this? Because if I leave it like this, which is in this form, I cannot solve my problem. So I need to express that using that first law. Break it down using this first law. And you know, when you still combine this, you arrive at this. Why should we do this? What we know is the logarithm of 2. The whole of this is known. The whole of this is known. So that we can easily substitute. Use this to replace this. Use this to replace this. Because we cannot replace them here. Cannot use this there. This is not 2. The whole of this is logarithm of 2. So we need to still break this down to log 2 and log 3. That's why we have to do that. So quickly, we now substitute. Having done that, having carried out this step, express the unknown logarithm in terms of the known logarithms, then substitute the values of the known logarithms into the expression and simplify to obtain your answer. So what is now log 2? They say substitute the values of the known logarithm into that expression now. What is log 2? Log 2 is 0.3010. And what is log 3 in base 10? 0.4771. When you add this 0.3010, 0.4771, in addition 18770. So we have 0.7781. So log 6 in base 10 will give us this. If we decide to go through it again, we follow our step, take note of the unknown logarithm. The unknown logarithm here is log 6. They said again, take note of the known logarithms. The ones that were given to us is logarithm of 2, and logarithm of 2 and the logarithm of what? Of 3. They now say, express the unknown logarithm in terms of the known logarithm using appropriate laws of logarithm. So we say there are two things that we can use to break that number, two operations that we can use to break the numbers. The number in terms of the numbers of the known logarithm. We say it's either we do multiplication and we do division. So here it is convenient for us to say 2 times 3 to give us what? 6. That's why we apply multiplication base. Now, having looked at this also, we said we have not applied the law of logarithm. So we need to apply the law. And the law we applied here is the first law that can still break this down. Remember that first law again. Log m in base a plus log m in base a is log in their common base m times n. So the whole of this is in this form. But if it is still in this form, it cannot help us to get the answer we are looking for. So we need to take it to this form. So we pull this to this, and that's why we have to break this into this. And then we now substitute to arrive at our answer. Okay, we'll take another question. The next one is question B. We are asked to find a log 24. Log 24. Okay. Remember the known logarithms are log 2 and log what? Log 3. So if anyone decides to say, oh, I know that 24 is 2 times 12, you'll be making a mistake because you don't know the logarithm of what? Of 12. They did not give us the logarithm of 12, so how can you possibly do that? So we'll work based on 2 and 3. So how many 2's are in 24 and how many 3's are in 24? So the only way to do that is to divide 24 using 2 and 3. 2 divide this will give me 12, 2 divide this will give me 6, 2 divide this will give me 3, and 3 divide this 1. So 24 actually contains how many 2? 3 2's. So 24 can be written as 2 raised to the power 3 times 3. That's 24. And I know that there are so many ways of writing 24. We can still write 24 as 8 times 3, 4 times 6. But they did not give us the logarithm of 6. They did not give us the logarithm of what? 8. So we need to write that 24 in terms of the logarithm of the in terms of the known logarithms. That's in terms of the numbers that their logarithms are known. And here, the numbers that we know that their logarithms are known are 2 and the word and 3. That's why we have to break it down to this one. So this will now give me log 24 is 2 raised to the power 3 times 3. At least we know how we arrived at that. So we move on. Still applying the first law. We have done that before. Log m more in base a plus log n more in base a will give me log n more times n more in base a. So this is in this form. So we need to take it like this. So this form now, let's push it back here. We write it as log 2 raised to the power 3 in base 10 plus log 3 in base 10. Okay, we have one more thing to do before we substitute. Remember, what they gave us is log 2 and not log 2 raised to the power 3. So we have this man that is disturbing our movement. That's this 3. But don't bother already. You know, so many people may begin to shout, oh, how am I going to do this? And by that time, you see students doing a lot of panel beating on mathematics. They will just be doing anything. Somebody will just say, okay, this 0.301 raised to the power 3. No, that's not true. That's not true. When we see that this is a stumbling block, but we can actually overcome it. It's not a problem because we know that there is a law in logarithm. The third law, to be precise, when the power is on the number. You see why you need to master these laws. When they are part of you, when you meet a problem, you now know the next thing to do. It will make you to think. So when I'm looking at this, I know I cannot possibly carry out substitution now because of this man. So I need to remove this man so that I can do my substitution. And how am I going to do that? You know, we say using appropriate what? Laws. Appropriate laws. So we have used the first law. There is another law to be applied. There's another law to be applied. So if we do that, we have P log n more in this way. So if this is now in this form. But leaving it in this form will not help us to solve our problem. So let's take it like this. This. You see the beauty. So if we do that, we are going to have now, this will now become 3 log 2 base 10 plus log 3 in base 10. Beautiful. So now we have the power to substitute because we now have we have set log 2 free. Before it's not free because of this 3. So we have set it free. It's now existing as log 2, and that is the value that was given. So if we substitute for log 2, what do we have? We're going to have 3 times 0.3010. This 3 is multiplying log 2, and log 2 is this, plus 0.4771. Beautiful. When 3 multiply this, we have 0.9030 plus 0.4771. Okay, let's add it somewhere here. 0.9030, 0.4771. Addition operation. We have 1. This will give me 0. You take 1 here. You know your normal addition. We have 3. And then you have that. So we are going to have at the end of the day 1.3801 as log what? 24. Oh, beautiful. Very beautiful. Very beautiful. So once you follow these steps, you will not have problem. As you are looking at this, immediately after now, you just go to your textbooks. Also look for past questions that contain similar questions, and then just begin to deal with them. That's the only way. You need to practice and practice and practice until these things become part of you. Okay, one more question before we go on a short break. You need to take one more, and that's want to find log what? Log 8. I believe you are taking note of this. You can actually pause this video from time to time so that you will actually comprehend what we are doing. Okay, question C now. Question C. Want to find log 8 in base 10. Someone will say, oh, how will I express 8 in terms of 2 and 3? Anyway, 3 will not come in here because 3 is not a factor of what? 8. So we can only use 2. And how many 2's? How many 2's are in 8? You have that. How many? 3. So I can write 8 in terms of 2. Why am I writing it in terms of 2? Is because I know the logarithm of what? Of 2. So this man is disturbing us. So how are we going to get rid of it? Applying the third law, this becomes 3 log 2 base 10. Okay? And finally, what do we have? We have 3 times log 2 in base 10 is 0.3010. When you multiply, you have 0.9030. That's what you have. So you see the 4 simple steps. You see, by the time you do this and do this, you don't need to be returning to the steps again. The steps will now become part of you. Alright, we are going to go on a short break. And when we return, we are going to solve the remaining 2 questions. That's what we are going to do. Remember, a meal a day is important. Very, very important. You need a meal a day in mathematics. That meal is necessary to keep you mathematically healthy. Many people are mathematically sick. Many people have mathematical kwashiorkor. Many have mathematical epilepsy. But only those that watch mathematics meal and only those that take mathematics meal will be free from all these mathematical sicknesses. Thank you and God bless you. Remember, you need to subscribe to our YouTube channel and like our Facebook page. It will go a long way in actually spreading this video to other people. Thank you and remember this.